I'm just saying I can't take it seriously when he sings for some reason.
Why?
Alrighty, so
Okay, just draw
1.3 properties of addition. So we have this additive identity. What's identity mean?
ID.
Like it looks, like who you are, what someone is, what describes them. Okay. So like on my driver's license, okay, it has my some identification information because it can be used as an ID or an identification. So it has like my height, my weight, my hair color, where I'm from, where I live, those kind of things. So details about someone or about something, so you can tell them apart. Okay. So we have this additive identity. So the additive identity, okay, it's just saying that the sum of any number and 0 is equal to the number. Basically, if you add 0 to anything, you just got the original number, didn't you?
Yeah.
So it's saying, and it's called the identity, because if you add 0, it doesn't change it, okay? Like if I change clothes, does it change actually who I am?
Yes.
Okay, no, unless I'm like Batman, like I put on the mask or something like that, But anyway, so in symbols, we can write, my goodness, that is like severely off calibration. Okay, that's gonna bug me. Alright, fix that.
I've been waiting for you to do this for a long time.
Well, the other day it was okay, but then it was bad today. So I'll play the calibration game. Oh, 5 out of 5 stars. 5.
Me too.
Alright, so a plus 0 is just equal to a. So any number a is just a variable. It could represent any number at all, okay? And if you take any number, you add 0 to it, you get the original number, okay?
Is that an O or 0?
It's a 0. Yeah, it's a 0. Okay. Jack, give me a number. 7. So if I take 7 plus 0, what do I get? 7. That's an example of it. Isn't that pretty neat?
So basically both examples.
Yeah, they're both examples. One's just using variables because that shows it always works, and then one's using numbers to say, hey, here's something we're more used to. Yeah. So then we have the additive inverse. Does anyone know what inverse means?
Opposite.
Yeah, it really means like you're doing the opposite, okay? So the additive inverse. So the sum of a number and its inverse is 0. It gets us back to the identity, okay? So the numbers are quote-unquote opposites. So if we had a plus a negative a, very good, we would get 0. We take any number and we add the negative version of that number, we get 0.
Math.
He's talking to the hot hallway.
Talking what?
To the hallway. He's like knocking. That's called more.
Okay. Anyway, pretend that didn't happen. Okay. Raquel, give me a number.
Let's go with 11.
11. So 11 plus negative 11 would give us what? 0. So anytime you add the opposite or the negative of that number, you get 0. Okay. Now what would we do if I started with, just for an extra example, you don't have to write this down. What if I started with negative 5? What would I have to add to that to get to 0?
Positive 5.
It's positive 5, okay? And that's because the negative of a negative, the opposite of a negative, my goodness, the opposite of a negative
Goodness.
is a positive, okay? So that's because this is the same thing as saying minus, or excuse me, oh yeah, that's the same thing as saying minus negative 5. It'd be the same thing, right? 2 negative signs in a row. Here we subtract, it's like you're adding a positive. Okay? Commutative property of addition. So you guys might remember hearing about commutative property, associative property, don't know which one's which, that kind of thing. Okay, commutative property, the order in which you add numbers does not change their sum. So whether you have A plus B, or if you have B plus A, it's the same thing. If you have A plus B, or if you have B plus A, it's the same thing, okay? So Isaac, give me a number.
1.
Okay? Alice, give me a number. 8. I know it's like really tough, like thinking of a number when I'm asking you for one, right? Okay? And that's going to be the same thing as if we had 8 plus 1. 1 plus 8 gonna be the same thing as 8 plus 1 because, Eli, what's 1 plus 8?
9.
9. Okay, well, Jocelyn, what's 8 plus 1? 9. So it didn't matter the order we added them in. Okay, it didn't matter the order we added them in. Okay? It'd be like saying, okay, well, if I'm starting out with 3 bags of peach rings because they're delicious, like Peachos, okay, and I go to the store and I buy 2 more, how many do I have in total? 5, okay? Let's say Haven starts with 2 bags. I started with 3, this many. He started with 2, okay? He goes and buys 3 more. How many bags does he now have? 5. Didn't matter how many we both started with or how many we bought, since they were the same numbers, just switched around, we end up with the same amount. So we also have the associative property. Associative property, the way you group numbers when adding does not change their sum. So if I have A plus B in parentheses plus C, that's going to be the same thing as A plus the B plus C being in parentheses. So if the parentheses are around the first 2 or the last 2, it doesn't matter for addition. For addition, it doesn't matter. Now once again, this is not saying for subtraction on any of these, but this is for addition. Okay? Josh, give me a number.
4.
4, okay, sorry. I thought you said but now I realize you said 4 both times. Okay? Jade, give me a number.
12.
12. Ava, give me a number.
5.
Okay. Ooh, purple's the wrong color for this. All right, so 4 plus 12 plus 5, 4 plus 12 plus 5. The difference between the two, on the left side, parentheses around the 4 and the 12. On the right, parentheses around the 12 and the 5. So according to order of operations, we'd go inside the parentheses first, right? So 4 plus 12 is 16 plus 5. On the right side, we go inside the parentheses first, so we do 12 plus 5, and we get 17. So now on the left we have 16 plus 5. What is 16 plus 5? Adding on, okay? And then what is 4 plus 17? Adding on, okay? So either way we got 21, didn't we? So did it matter the order we went in? No. Now did we say this is or isn't true for subtraction?
Not.
It's not true. We tried that last class, didn't we, okay? Now, here's the thing. Here's the thing. Even though these properties aren't necessarily true for subtraction, you can change subtraction into addition. You can always change subtraction into addition, okay? This isn't in your notes, but you can write, but you can just look at this up here. So if I have 4 minus 3, and I have 4 plus a negative 3, it's going to be the same thing, whether you're subtracting a positive number or you're adding a negative number. It's really the same thing. Subtracting is the same thing as adding the negative, okay? It's like adding the opposite of whatever is there. So whenever we have subtraction, I can always change the subtraction problem into an addition problem. I just have to change this subtraction to addition, and I have to make whatever follows that, whatever we were subtracting by, the opposite sign. So if it's positive, it becomes negative. If it's negative, it becomes positive. Okay? So either way, we end up getting 1, right? Questions on that idea, how you can change any subtraction problem into an addition problem? Now once you change this into addition, now you can use these properties. Now you can rearrange them, now you can add them in any order. But you just have to make sure that this 3 stays a negative 3 the whole time as you move it around or as you do anything else. Now we're going to try and identify different properties as they're used. So something I like to do to help us figure out which property is which is commutative. Commutative, I kind of see the word commute in there. Does anyone know what commute means? If somebody's commuting?
Driving
It's like they're driving, they're moving, okay? They're moving around. So I commute to school every morning. You guys commute to school every morning, okay? So you're moving around. What's happening in our property? Our numbers are moving around. They're switching up where they're located, okay? So it's right in the word there. Now associative, I like to think of associate, Okay, like you're associating with someone. What's it mean when you're associating with someone?
Talking.
Okay, you're talking with someone. You're with them. You're kind of grouped together with them, aren't you? Okay. Parentheses is how we group things. Okay. So the associative deals with associating, and that's how we group things. So it's saying the way we group things in parentheses does not matter for adding. Okay. So that might help you a little bit to keep these a little straight. So right below here, okay, we're going to name the property of addition as being shown in each of the statements. So our first statement, 4 plus 3 is the same thing as 3 plus 4. So what property is this showcasing? Is it showcasing our identity, our inverse, the commutative, or the associative? Okay, Abby, what are you thinking? It's showcasing the commutative. Why do you say that?
Because it said 4 plus 3 will still be the same as 3 plus 4.
Yeah, it's saying the order we add them in doesn't matter. If we move them around, they're commuting around in a different order from the left to the right side, it's gonna be the same. Okay? On the second one, okay, be very careful as we look at this one. Be very careful as we look at this one. What are you thinking it might be here, okay? Courtney, what are you thinking? Okay? Imagine you're going to disagree. Do our parentheses actually change?
Oh no.
No, tricky. Mr. Carlson got tricky around for that. Okay? What's changing here, though?
The number.
The order they're in. The order they're in, where they're located. So they're commuting around again. So just because we see parentheses doesn't mean it's automatically associative. We have to say, okay, are we changing where the parentheses are? Okay? Or are we changing where things are located? Okay? Because those are two different things.
So like moving around, do you mean like if they're here this problem, it'd be like here the next problem?
Correct, yep. So it'd be like, so this would have been, well, let's look at example 8 real quick. Okay, let's look at example 8 real quick. Is it in this? Are the numbers and variables in the same order left to right on each side of the equal sign?
Yes.
Yeah. Okay. So it's not commutative. Commutative means they changed where they're located. But
Okay.
here, parentheses around the first two. But here, where's the parentheses?
On the last.
Last two. So this one would be
No, it's
associative, because it's just changing where the parentheses are, not where the actual numbers and variables are. Okay, tricky. Okay. So I want you guys to actually try working on 3 through 7 here. I want you guys trying to work on 3 through 7 here. Okay, we did 1, 2, and 8 together. You guys try on 3 through 7. Oops, heads up here on number 4. Mr. Carlson made an oops here. Okay, needs to correct it. Number 4, 0 plus n equals 1.4. This should be 0 plus n equals n. Okay, that should be 0 plus n equals n. Okay. Bless you. And bless the reading on Africa. Bless you, forget.
What did you say?
I wanted to make sure we bless the rains down in Africa too. You know, like the song Africa by Toto.
No.
All
I know
played.
that song, but
So Ava, what did you put for number 3? Commutative. I agree. I put communicative on the second one. Whoops, I spelled that wrong. Okay. I spelled that doubly wrong. There we go. And then Ava's right, number 3 is the commutative as well. Because the 8 and the 5 are changing spots. Okay, 8 and the 5 are changing spots between the left and the right side there. Okay? So even though we have parentheses, the parentheses aren't changing spots. The actual 8 and the 5 are. Okay. Number 4, 0 plus n equals n. Anyone want to volunteer for this one? Haven.
Additive identity.
Yep, this is the additive identity. Okay, this is the additive identity. If you just want to put identity on this one, for today, I'm okay with that. Now later on, we might be mixing up the additive identity and the multiplicative identity. So when that happens, you'll have to say additive. But for today, I'd be okay with just putting identity. Okay, does that make sense? Today I would be. Later on, we're going to be mixing them together, so it would need to be more specific. Okay, so we're just saying any number plus 0, you get the same thing. Okay, it stays itself. No matter if you add on a 0, if I throw on a jacket, okay, it's still the same as possible. D plus negative D equals 0. Emily.
Additive inverse.
Very good. That would be the additive inverse. And same thing on this one. You could just write inverse for today if you want. But once we start adding in the multiplicative, we would need the word additive. Okay. So additive inverse saying, hey, if we do the opposite, we're going to get back to 0, which is our identity. Okay. Brady, what about number 6? Yep, very good. This is the additive identity as well, saying that, hey, if we add 0 to something, we're going to get the same exact thing. Okay. Number 7, a plus 8 equals 8 plus a. A plus 8 equals 8 plus a. Sarah.
Commutative.
Commutative, very good. We're just changing the order these are in. Okay, that's notes. That's 1.3. Okay, so I do have a small worksheet for 1.3 because I'm just so fun. I love doing worksheets. Okay, they're my favorite thing ever. Of course, right? Because I know they're your favorite thing ever. That's the only reason I do them, because I know you love them. You're welcome. You're welcome. You're happy to. Christian was telling me how much he loved them, so I'm like, oh, okay. So I just assumed he was telling me. So this is really the same thing we were doing, okay? On the top, we got some matching. We're just matching with a word bank, okay? There you go. Worth a try. Okay. And on the bottom, 5 through 12, we're doing the same exact thing we just did, okay?